On the harsh battlefields of World War II, a soldier's survival often relied heavily on how dependable their standard-issued gear was. Yet, due to supply problems and hurried design processes, many troops were equipped with seriously flawed weapons that put their lives at risk. In this overview, we examined several frontline firearms that soldiers came to hate, highlighting the specific mechanical issues that caused them to break down at the worst possible moments. First on our list is the M50 Reising submachine gun, an American firearm initially issued to Marines in the Pacific Theater due to severe shortages of standard heavy submachine guns. This weapon was originally manufactured to strict civilian police specifications, resulting in tightly fitted internal mechanisms that were entirely unsuited for gritty frontline environments. The Reising suffered from extreme unreliability, constantly jamming as soon as the receiver was exposed to mud, sand, and salt water during island combat. Furthermore, the charging handle was awkwardly positioned inside a recess beneath the forend, making it exceptionally difficult for a soldier to quickly clear a malfunction while under heavy enemy fire. The situation became so dire that officers famously ordered their units to throw these submachine guns into rivers and search for bolt-action rifles instead. Ultimately, this firearm serves as a primary example of why delicate civilian engineering fails under the harsh realities of World War II combat. Next, we have the Type 94 Nambu pistol, a compact Japanese sidearm widely regarded by military historians as one of the most dangerous and poorly designed service pistols ever adopted. Issued primarily to tank operators and flight crews who required a smaller weapon, this firearm featured a catastrophic engineering flaw in the form of an exposed sear bar positioned on the left side of the receiver. If a soldier merely bumped this external bar, pressed it against the tight confines of a vehicle canopy, or even holstered the weapon improperly, the pistol could instantly fire a chambered round without the trigger ever being touched. This critical defect caused numerous lethal accidental discharges, making the weapon a severe hazard to the very operator carrying it. Additionally, the pistol fired an underpowered 8mm cartridge and required a deeply complicated disassembly process that frustrated users in the field. Consequently, soldiers heavily distrusted the sidearm, treating it as an active liability rather than a tool for personal defense. Let us continue with the Breda Modelo 30 light machine gun, the standard squad support weapon issued to the Italian army throughout the conflict. This complex firearm operated on a delayed blowback system that lacked the necessary primary extraction power to smoothly eject spent cartridge casings. To prevent brass cases from tearing apart inside the chamber, engineers installed an internal oil pump designed to lubricate every single round before it was fired. Unfortunately, in the arid desert battlefields of North Africa, this constant stream of oil immediately attracted blowing sand and dust, creating a thick grinding paste that caused constant jamming. Furthermore, the weapon relied on fragile 20-round brass stripper clips, which drastically reduced the overall volume of fire a squad could project during an engagement. Soldiers completely despised this over-engineered weapon because the exhaustive maintenance requirements made it almost entirely useless in sandy operational environments. Moving forward, we examine the projector infantry anti-tank, commonly known as the PIT, which served as the primary portable anti-armor weapon for British infantrymen. Unlike rocket-propelled launchers, this system utilized a heavy spigot mortar design, offering the tactical advantage of having no dangerous backblast. However, soldiers universally hated this device because it weighed a grueling 32 pounds unloaded, placing an immense physical burden on the operator during long marches. To prime the weapon, a soldier had to stand up under enemy fire, place their feet squarely on the shoulder pad, and heave upward with massive physical force to compress an incredibly stiff mainspring. If the brutal recoil of firing failed to automatically recock the mechanism, the exhausted infantryman was forced to repeat this terrifying manual process in the middle of a frantic firefight. The combination of excessive weight and a physically punishing reloading sequence made it one of the most dreaded weapons to operate in the field. Next on the list is the WW41, an early semi-automatic rifle developed for the German army to compete with advanced Allied firepower. The design of this rifle was severely compromised from the beginning because military bureaucrats explicitly forbade engineers from drilling a standard gas port directly into the barrel. To bypass this restriction, manufacturers utilized a complicated gas trap system located at the extreme end of the muzzle, making the rifle front-heavy and poorly balanced. During prolonged engagements, this delicate muzzle trap rapidly accumulated thick carbon fouling from the corrosive ammunition used during the war. If the soldier failed to meticulously clean the trap daily, the internal mechanisms would seize up completely, turning the advanced rifle into a heavy, clumsy, manually operated weapon. Troops thoroughly despised this initial model until it was replaced by improved designs later in the conflict. Now we look at the Sten gun, specifically the early production models that provided crucial firepower for British forces and resistance groups. While historians praise its cheap stamped metal construction for aiding the war effort, the soldiers forced to carry it had a different perspective. Troops deeply hated the crude open-bolt design, which was notorious for causing accidental discharges if the weapon was dropped onto a hard surface. Moreover, the firearm used a flawed double-stack, single-feed magazine system that was highly prone to feeding failures when exposed to battlefield debris. Soldiers often avoided holding the weapon by its side-mounted magazine, as even slight pressure could misalign the feeding angle and cause an immediate jam during close-quarters combat. Ultimately, it was an uncomfortable, poorly balanced weapon that troops only trusted when no better options were available. Continuing down the list, we have the Boys anti-tank rifle, a massive 5-foot-long weapon originally designed to counter early armored vehicles. By the time World War II intensified, advancements in enemy tank armor rendered this rifle largely obsolete. Soldiers forced to carry this 35-pound weapon across the battlefield hated it because the physical burden far outweighed its diminishing effectiveness. When fired, the large .55 caliber armor-piercing round produced brutal recoil, causing severe shoulder bruising and neck injuries, even with padding and a muzzle brake. The concussive force made troops dread using it. Eventually, it was phased out, leaving a legacy as an excessively heavy and painful weapon to operate. Next, we examine the Type 11 light machine gun, an early Japanese squad weapon with a highly unusual and flawed ammunition system. Instead of detachable magazines, it used an open hopper feed tray on the side of the receiver. Soldiers had to continuously insert 5-round stripper clips into this hopper while the weapon was firing. This exposed design allowed dirt, mud, and debris to fall directly into the internal mechanism, causing frequent and severe jamming, especially in jungle environments. The weapon required constant cleaning, which compromised the unit's ability to maintain sustained fire. Infantry units despised relying on such an unreliable system in combat. Finally, we conclude with the Krumlauf, a curved barrel attachment designed for German assault rifles to allow soldiers to shoot around corners or from inside armored vehicles. While the concept seemed innovative, frontline troops viewed it as a dangerously flawed gimmick. The extreme friction within the curved barrel caused bullets to fragment mid-flight, making accurate targeting nearly impossible. Additionally, the intense pressure and heat quickly damaged the attachment, causing it to warp and fail after limited use. It also disrupted the weapon's balance, making it awkward to handle. In the end, soldiers preferred traditional combat tactics over relying on such fragile and impractical experimental equipment that often failed during battle.